Okay, today we're going to be discussing the metric system and how it relates to the SI base system. The SI base system is the prefix with metric system to give us a value number in science. Here we have a number line that indicates the SI base system. We have a 10 to the negative 9 all the way 10 to the positive 9. There are larger numbers. It goes higher than 10 to the negative 9 because we have 10 to the negative 12, which is a picometer, and 10 to the positive 9, which is a tera meter, and those are something that is kind of common knowledge to some people. But what I want to get here into is kind of the specifics here. We have the base 10 to the 0 or 1 or 2 or 3 exponents, depending on which one ever we're talking about. Here I'm talking about 10 to the 0, here is 10 to the 2, and there's 10 to the 3. Those are just some common ones, and what that really means, what a 10 to the 0 means, and what a 10 to the 2, or a 10 to the negative 2 is really an indication of how many decimal places is moved. So if you come down here and read, see 10 to the 0 right over here specifically indicates how many decimal places does that 10 have, or that 1? Because 10 to the 0 is really 1. So standard is actually 10.0. And so 10 to the 0 is really how many zeros are after the 1. So if you want to, you can consider the exponent of how many zeros that are after the 1. For example, we have 10 to the 0 right here. How many zeros are after the 1? Well, 0. There are 0 zeros after the 1. So that becomes 1.0 because there are no zeros after the 1, except the one after the decimal point, and that one, of course, doesn't count. That doesn't factor in. So another example, 10 to the 1. There is 1 0 after the 1. So 10 to the 1 equals 1.0, and I move that decimal over one place, so now I have 10. So I have 10 right here, because there is 1 0 after the 10. If I were to go 10 to the 5 up here, I would have 10 and then 5 zeros. 1, 2, 3, 4, 5. Easy does it. That's a pretty easy thing to grasp. Another more encompassing way that is more technically sound, and it's a more correct view, is the exponent indicates how many times you move the decimal, and that's kind of important. The exponent these exponents really indicate how many times you move the decimal to the right or to the left. If you have a positive exponent, you move it to the left. If you have a negative exponent, you move it to the right. So here they move to the left here. So you're moving the decimal. I apologize, I said that backwards. For a positive exponent, you move it to the right. For a negative exponent, you move it to the left. So here, it's 10 to the 2. 10 to the 2, I'm taking my decimal at, it starts at 1.0, and I'm moving it 2 decimal places. So it's going to equal 1, and I take that decimal 1, 2 places, so I have 10 to the 2, that equals 100. Not too complicated there. I think we've seen stuff that before. So you come down here and read. Here's some other examples. If I have 10 to the 0, that equals 1.0, and you move the decimal 0 places. So 10 to the 0. The 0 indicates how many places you move the decimal. Well, I move the decimal 0 places. Here I have I have 10 to the first, or 10 to 1, and so I move the decimal 1 place. As we see right here, the decimal was originally in between the 1 and the 0, and I move it 1 place to get 10. So anything raised to the first power is that number. 2 to the first is 2. 4 to the first is 4. Well, 10 to the first is 10. As seen above, we move the decimal to the right 1 place. Now we have a tricky one, 10 to the negative 4. Well, again, we move that one to the left 4 places. So if you watch with me here, originally it's in front of the 1. So I move it 4 places. 1, 2, 3, 4. So now I have 0.0001. And here's something for people to easily remember. When you have a negative exponent, the number of zeros you have is 1 less than the exponent. So if I have a negative exponent, say I have 10 to the negative 6, can we guess how many zeros I'm going to have? Well, I'm going to have 5 zeros. If we look over here, I have 10.1 to the negative 6, and I convert that, I move that over 5 places, so it's going to be 1, and it's going to be 1, 2, 3, 4, 5, 6. Move that over 6 places. 1, 2, that's 3 zeros. That's 4 zeros. That's 5 zeros. So I moved over 1, 2. I'm sorry. This 1 is 1, 2, 3, 4, 5, 6, and I have that there as for 5 zeros, as we can see. But for positive exponents, the number of zeros you have is the exact same number of exponents. So if I have 10 to the 6 here, I know I'm just going to have 6 zeros afterwards. So that's because my exponent is here, and I'm going to move it over 1, 2, 3, 4, 5, 6. Well, that's 1, 2, 3, 4, 5, 6. That equals 1 million. That's 6 zeros there. So let's have a little compare and contrast right over here. We have 10 to the negative 3 and 10 to the positive 3. Well, as we have said before, we can already, before we even finish the problem, we can expect that I'm going to have 2 zeros for the negative 3, and I'm going to have 3 zeros for the positive 3. So let's do our problem. Here I have 10 to the negative 3, and remember, I'm starting with 1.0. That's what I'm starting with. So right here I have 1.0, so I could put the 0 right here if I wanted to. And I move my decimal to the left because it's a negative exponent. So I move it to the left 1 time, 2 time, 3 time. That only leaves 3 zeros because the 1 takes up a decimal place. That's why I don't have 3 whole zeros, because the 1 already takes up a decimal place. So you compare that then to the positive exponent. I'm not moving my decimal past the 1. I don't have to worry about the 1. So the 1 isn't going to take up a decimal place. So I move it over 1, 2, 3, and I have 3 zeros, as I said before. So and easy to remember that. So I'll come back up here, and I want to know how many zeros does this 10 to the negative 5 have. I know it's going to have 1 less than 5, so it's going to have 4 zeros. And sure enough, I move that over. It's going to be 0.00001. And we're going to take that back. It'll be, that's moved 5 places. 1, 2, 3, 4, 5. 5 places. That's a pretty easy way to memorize that, so people don't get mixed up, I believe, however. Now, with the metric system, the metric system is used as a prefix system for my SI-based systems. As we've discussed before, the SI-based system is a unit of measurement for measuring different objectives. Meters, length is meters, seconds is time is measured in seconds, temperature is measured in Kelvin, and so the SI base unit itself is the unit that we're talking about, and the metric system is the prefix that describes how much of that unit is present. So the metric prefix indicates the exponent we use, and the unit symbol indicates what SI unit our measurement is in. So if we come over down here and we look, we have nanometers. Well, that nano is the metric prefix, and the meter is the SI base unit. Okay? So, well, what's my metric prefix? Well, what is nano? We come back up here to our number line. We come back to our number line and we say nano is 10 to the negative 9. Well, that's 10 to the negative 9. That means a nanometers have 10 to the negative 9 meters. Of course, you're going to be asked to memorize this number line with a different exponent. You're going to have to know that nano is 10 to the negative 9 and its symbol is N. Micro is 10 to the negative 6 and its symbol is the Greek letter from U. And we see right here it's the kind of long U. Milli is the 10 to the negative 3 and its symbol is M, and so on and so forth. You're going to be asked to memorize those all the way over to giga. We come back down here. Here's another example. We have milligrams. Milli, again, milli is the metric prefix, while second is the SI base unit. Okay, so I have milliseconds. Well, what is that millisecond? Milli, like we said, was 10 to the negative 3 seconds. That's how many seconds I have. We've come up over here. Here's the number line again. And so, just so people don't get confused, that number line goes from -9 all the way to +9, and in the dead center there is 10 to the 0. The 10 to the 0 is the standard unit, as we see right here. It's a standard unit. So if I have 10 to the 0, I have 1 of anything. I have 1 meter, 1 second, 1 gram. So if we come down and we see a unit without a prefix, we understand automatically that it's a single unit. So if I see something that wants me to convert something into grams, and it doesn't have a prefix, it's missing that prefix right here, well, automatically know that is 10 to the 0 grams, or 1 gram. So, because remember, 10 to the 0 is the standard unit here. Now, go back and look over here. Let's do some more practice problems. If I have 1 millimeter, that milli right over here, the first little m is the metric prefix, while the second little m is the base unit we're measuring. So the first is the milli, and so milli we understand is 10 to the -3, and the meter is the length, it's meters right there. We have 10 to the -3 meters. Okay. Go over here. Let's look at gigaseconds on the other side of the table, of the number line. And so giga, as we understand, is the metric prefix right here. That's the metric prefix, while second is the SI base unit for time. So gigaseconds. And well, obviously that's going to be a large second, because giga is all the way over, we see 10 to the +9. Well, what's that going to be? That's going to be 10 to the +9, and as we've said before, that's 10 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is a billion seconds. 1 gigasecond equals a billion normal seconds. We go back up here to this millimeter. Well, as we said over here, this millimeter is 10 to the, well, how many zeros should I have? If it's 10 to the -3, how many zeros? It's 1 less than 3. So that is 0.001 meters. Because I have 2 zeros before my decimal. I hope that clears some things up.